Let's solve a problem on gravity. And let's say we have a binary star system, which means there are two stars and they are rotating against each other. And let's say they are rotating about this point. And they have the same mass, m. So these two stars are going in a circle around this point. And if this guy is going at a velocity of 3 multiplied by 10 to the power 3 meters per second, and the distance between them is 10 power 7 meters. What is the mass of stars, or what is m? Okay, so two stars of the same mass rotating about a central point, and the distance between them is 10 power 7, and the velocity by which they are rotating is 3 multiplied by 10 to power 3 meters per second. So we have to find the mass of this star. How to do that? Well, we know that there's a force of gravity acting between them. And what is the force of gravity? Well, the force of gravity, Fg, is going to be g multiplied by m times m divided by r square, which is going to be 6.67 multiplied by 10 power minus 3 multiplied by m square divided by r square, which is 10 to the power 14. Well, I'm sorry, this should be actually 11 multiplied by m divided by r square, which is 10 to the power 14, because 10 power 7 multiplied by 10 power 7 gives you 10 power 14. Okay, now this force of gravity is the one which is providing the centripetal force or centripetal force to these stars. Now what is the centripetal force of this guy going around this central point? We know that this star is going around this star, this central point with some velocity, and the radius from the central point is 0.5 multiplied by 10 power 7 meters. And how much is the centripetal force that is required for this star to go around this central point? We already know the formula, which is m v squared over the distance. We already have used r here, so let's just put that distance here, which is let's call this r over 2, because we already have used r for the whole distance. So this is actually half of r, so this is r over 2. This is not really a good way of writing, so let's just write minus 0.5 multiplied by 10 power 7. Now we know that centrifugal force is going to be m v squared, which is 3 multiplied by 10 power 3 squared divided by the radius. So we know that F centripetal is given as mv squared over r, where m is the mass of the object, v is the velocity by which it's moving, and r is the radius from the point about which this mass is going in circles. Okay, so this is 0.5 multiplied by 10 power 7. So this is the centripetal force. Now the gravity is the one that is providing this centripetal force. So it should be 6.67 multiplied by 10 power minus 11 multiplied by m squared 10 power 14 equals, and this gives us 9 multiplied by 10 power 6 m divided by 0.5 5 multiplied by 10 power 7. So that gives us m equals, well, that gives us m equals 6.6. Well, it's a long calculation, but let's say it should be 90 divided by 5 multiplied by 6.67 times 14 plus 6 is 20, 20 plus 11 is 31, 31 minus 7 is 26. So 10 to the power 26 kilogram. That's a lot of mass. But anyway, we were just interested in doing a problem. And this looks like it's close to something like 1.3. You can use your calculators and find out the exact answer, but this is something like that. Okay, is it 1 point? No, actually should be around equal to 2.3, something like 2.3. Anyway, so we have calculated the force of gravity between the two mass, and is the force of gravity that is providing the centripetal force, and we set up this equation here to find the mass of the object, mass of the star. Actually, it's a binary star.